Have you ever clicked a link and just kind of paused for a second and wondered what actually happens next? Well, today we're going to follow that one single click on its incredible, completely invisible journey across the internet. You know, it really isn't magic, even though it feels like it. It's more like a perfectly timed symphony of technology that sends a request from your screen across the globe and back again, all in an instant. And it all starts with learning the rules of the road. So, before our click can even think about starting its journey, it has to know the rules of travel. Basically, the official language of the internet. Okay, so for computers all over the world to talk to each other without total chaos, they need a shared grammar, right? That's where reference models come in. The most famous one is the OSI model. Think of it like a blueprint that breaks down this impossibly complex process of network communication into 7 distinct, manageable layers. But here's the thing. While the 7-layer OSI model is the official textbook version, the internet we actually use every day runs on the more streamlined TCP/IP model. It's a classic case of theory versus reality. The TCP/IP model basically combines a few of those layers because, at the end of the day, it's just more practical for getting things done quickly. Now, at the transport layer, our click's little message gets packaged up for its big trip, and it gets 2 main choices. There's TCP, which is like sending a tracked package. It might be a little slower, but you get a guarantee that every single piece arrives and in the right order. Or you can use UDP. Think of that as sending a postcard. It's super fast, but there's no guarantee. It's absolutely perfect for things like video streaming or gaming, where speed is everything and losing a tiny piece of data here or there is no big deal. So, our data packet is all ready to go. Now for section 2, the digital roads. We've got to find the actual paths and addresses for this journey. It's so easy to forget this, but the internet is a physical thing, and this whole journey happens on real hardware. Routers and switches are the absolute unsung heroes of the internet, making billions of split-second decisions. Routers are like the major highway intersections, directing traffic between completely different networks, while switches are the local roads, handling all the traffic inside your home or office. And here's the kicker. These devices don't just work magically out of the box. Nope. Network engineers have to use this very precise text-based language to give them instructions, telling a router exactly what its name is, how to secure itself, and precisely how to manage the endless flow of traffic. Okay, but this brings up a huge question, right? For that data to find its way from a server halfway across the world back to your specific laptop and not your neighbor's phone, it needs a totally unique address. I mean, how on earth does that even happen? Well, the solution is this really clever and automatic process called DHCP. The very moment you connect to a Wi-Fi network, this protocol just springs into action. There's a special server on the network that acts like a welcome committee, ready to hand out a temporary, unique IP address to your device. And this all happens in 4 lightning-fast steps that people in the know just call DORA. Discover, offer, request, and acknowledge. Your device basically shouts out for an address. A server offers one up. Your device says, "I'll take it," and the server confirms the whole deal. Just like that, your device is officially on the map, ready to communicate with the world. Okay, so with an address and a path, our click's request finally reaches its destination, a super powerful computer we call a server. Now, that server is probably running one of 2 major operating systems. On one hand, you might find Windows Server, which often has that familiar point-and-click graphical interface you're used to. It's pretty common in corporate settings. But a massive, massive portion of the web, we're talking social media giants, streaming sites, you name it, runs on Linux servers, which are absolutely prized for their rock-solid stability and command line efficiency. So, the server has the data we want, but the return journey, that's where the dangers are. How do we make sure our data gets back safely? Well, to keep all that data safe, the network uses all these different layers of security. You've got firewalls acting as the main border patrol for the entire network. Then, right on the routers themselves, you have access control lists, or ACLs, which are like security checkpoints, checking the credentials of every single packet that tries to pass. And for maximum security, VPNs create a private encrypted tunnel. It's basically like putting your data inside an armored car, making it totally unreadable to anyone trying to peek inside. And just like that, our data has made it back safely and the content appears on your screen. End of story, right? Well, not quite. The whole architecture of this journey is already changing. I mean, just think about it for a second. Configuring every single router and switch by hand is painfully slow, it's really complex, and it's so easy for a human to make a mistake. The future isn't about manual tweaks. It's about making our network smarter, more automated, and able to react instantly. And this is where a truly radical idea comes in: software-defined networking, or SDN. What it does is it separates the brain of the network, the decision-making part, from the physical hardware that just moves data around. This centralizes all the intelligence in one software controller, and suddenly the entire network becomes programmable, agile, and just so much easier to manage. Now, when you take that programmability and combine it with the immense power of the cloud, you get something called Infrastructure as a Service, or IaaS. What this means is that basically anyone can get access to massive networking power, on demand, all managed by providers like AWS, Azure, and Google Cloud, without ever having to touch a single physical router. So, the next time you click a link, just take a second to remember that incredible, invisible journey you just launched. It's a journey that crosses physical cables under the ocean, speaks these complex digital languages, and navigates a maze of highways, all in less time than it takes to blink. And this all leaves us with one final thought. As the very fabric of the internet becomes software, that line between being a programmer and being a network engineer is getting blurrier and blurrier. The people building tomorrow's digital world are going to need to understand both code and connectivity, and that is creating a whole new, exciting frontier of innovation.